Okay, everything's in order. Welcome, Yama. Apologies again for the little delay. It's a pleasure to have you here. Your pioneering work in northeast part of the subcontinent, inland. It's I don't know how to describe it, but it's really exactly what I say, pioneering. And not only in the techniques, but also in the diligence and the completeness of the record. So I can't wait to see your talk.
Okay. Well, I'll just start right again. Like Livi said, I'll be talking about lake records from Northwest India, and the timing of the time period that I'll be talking about would be entire Holocene. Now, what you see here on the screen is actually a lake, which is turned into an agriculture land. So they grow crops here. But if you have a JCB or a digger and you dig inside like 1 meter down, if you discard the top 20 centimeters, 10, 20 centimeters, depending on how deep the crops have gone, you can see lake deposits. And the way to kind of identify lake deposits there are lots of shells. So the garden snails that you see, big shells under the ground. So these are paleo lakes. So this was a big lake at some point. This is located in Haryana, and now this cropland gets filled up during rainy season, but there's no lake here, and that's why we call it a paleo lake, or these deposits are called paleo lake deposits. And I'll be talking about some of them in this talk. Now, the idea of this talk is actually to kind of see whether these lakes, what were these records recording? What were these lake deposits actually recording? Was it the monsoon rainfall in congruence with the other global monsoon records or not? So let's just start right in. Yeah, so I won't talk about monsoon since it's a monsoon series where people have been listening about how monsoon works, the seasonal migration of the intertropical convergence zone, such that during the summers it's at the northernmost latitudinal position, and the energy transport that brings rainfall on the Indian subcontinent. And if we talk about the Indian subcontinent, it receives most of its rainfall between June and September, such that the monsoon can be sort of divided into two branches: the Arabian Sea branch coming from the Arabian Sea, and also the Bay of Bengal bringing moisture from Bay of Bengal region. Now, I'll be focusing on this blue square right here, and this is the Northwest India, and I'll tell you why this is important and why this kind of interested me in the first place. So this region actually has a very strong east-west gradient, such that the moisture coming from the Bengal region gives it a distinct character, and the sedimentology and the geochemistry of the sediments that are there in the soil of the ground, it changes a few hundred kilometers, which is not usual if you look at other regions, or for example, if you look at the core monsoon zone in central India, it won't change so rapidly, or at that rate within a few hundred kilometers. So sorry. Between June and September, and you can see that the temperatures are range around maximum. They go up to 35 degrees, and during the summer months, And in terms of the oxygen isotope precipitation, now this data is coming from the nearest GNIP station in New Delhi, and we're talking about Haryana lakes in Haryana, so not too far off. So the oxygen isotopes of precipitation in the region, as you can see, is kind of lower in the monsoon and post monsoon months, and the weighted mean of oxygen isotope is about minus 5.9 per mil. So looking at this data, and because this climatology, looking at the modern climatology, we can say that the lake archives in the northwest India, since it's 80% of rainfall coming from summer monsoon, should independently record the changes in monsoon history during the Holocene or whatever period that we're looking at, in this case, Holocene. So now I'm also interested in this region because of one more reason, which is that it was one of the highly populated region during the early to mid Holocene. Now, the orange dots that you see on the maps are all Bronze Age settlements. This data is from the archaeologists working at the University of Cambridge. Some of them are I haven't marked them, but some of them are really like urban centers, and while others are kind of settlements, village-based settlements. But these all belong to what was called as the Indus Valley civilization. And because these are Bronze Age, they are also contemporaneous with the Mesopotamian and Egyptian civilizations in further west. So this actually interests me that if we have the lake records, climate records coming from these lakes, which is quite in vicinity. So these are 3 lakes that I'll be talking about. This is in vicinity of these archaeological sites. It would be interesting to see what was the climate like that was recorded in these lakes, and whether or not they had any influence on the evolution of these societies. So like I said, these are the 3 lakes. So these lakes, going from east to west, these lakes lie in different climatic zones. So subhumid region, Kotla Dahar, is in about 600 to 750 millimeters rainfall. We have Rivasa in the semi-arid region, and then there's one which is in the border of Thar Desert in Rajasthan. So it is in the arid, less than 400 millimeters of rainfall. So before I start with the actual record, I would give you a brief introduction as to what I'm using for reconstructing these records. So I use these shells, like I talked before, that if you kind of dig straight in the ground vertically, you would find these shells. And interestingly, these carbonate shells, either aragonite or calcite, these would have recorded the isotopes of oxygen, which would reflect either the temperature changes in the region or the isotopic changes in the water that they were living in. So if we measure these the oxygen isotope of these carbonates, it could be a gastropod, and these shells are really like tiny, less than a centimeter, less than a millimeter shells, microscopic shells. These are calcitic, so astrocod and aragonite gastropod. Now, the oxygen isotopic composition of these carbonates would reflect the temperature and the waters that they were living in, so the lake water isotopes. Now, since we are talking about Holocene, and the temperature changes in the Holocene hasn't been too large to be documented in the scale of oxygen isotope that I work on, we would mainly attribute the changes in carbonate oxygen isotope to the oxygen isotope of water. And this in turn is governed by what was the oxygen isotope of rainfall that was falling in the catchment, in the lake, and as well as the catchment, and also the precipitation by the rate of precipitation and the evaporation. So how P by E changed during that period. Now, we know that the amount effect, how the Rayleigh fractionation work, and the amount effect, which is like if the amount of rainfall is higher, you get more negative values of oxygen isotopes recorded in the carbonates. So such as during wet period, when the amount is high, you have more of O18 and O18 and O16, and overall the isotopic values are depleted, and in general, low values, oxygen isotope values, would be interpreted as a wetter climate, while during dry periods we have high oxygen isotope values recorded in these shells. So, and then like you can find, if you're trying to see what the temperature is like, you can kind of have an idea if there was any changes in the temperature, and if not, from the water isotope you can correlate how the carbonate isotopes were changing. Now, if you have shells in the sediments, that's very good. You can use these techniques. In arid regions where there are not many shells, they're mostly evaporative salts. And one such salt is gypsum. Gypsum is calcium sulfate, which has two molecules of water. This is the hydration water, and if we kind of extract this hydration water and measure oxygen isotopes of this hydration water, this is independent of temperature changes, but it records the oxygen isotope of the lake water in which it was living in. So if we correct it with the fractionation factors, whatever fractionation that is that it has undergone, if we correct it for those, oxygen fractionation factor for oxygen and fractionation factor for hydrogen, we can get the exact values of oxygen isotopes of waters that it was living in. And if we have that, and also the shells in the same layer, so for instance, if you have gypsum in the same layer as the shells, you can get both the carbonate isotopes and water isotopes from gypsum, and in turn calculate exact temperatures, well, like relatively accurate temperatures during those times. But it's relatively hard to find because gypsum is an evaporative salt. So it's an evaporating water on land. It's an evaporating water body. That's when you get gypsum. There are instances of shells occurring at the same time, but it was difficult to compute the exact temperatures because the shells had undergone some sort of precipitation later on. So diagenetic changes, that we call it. But in any case, I'll be using these two gypsum hydration water isotopes and carbonate isotopes mainly for these two for paleoclimate reconstruction that I'll show. So the first lake that I'll be talking about is Kotla Dahar. It is in the subhumid region. And these are the three records that I reconstructed. So age is on the y-axis, and on x-axis you have percent weight carbonate, so how much carbonate is constituting the sediments. Oxygen isotope of this shell, which is a gastropod shell called Melanoides tuberculata. And also I looked at the counts of these. Now, I didn't use ostrocods for isotopes. It's because they were not continuously present. And I wanted a more continuous record. After a point, they just disappeared. So for people who don't do paleoclimate, this is the ground. And this is when I dig in, or when I get it dug inside under the surface of the earth. So as you go deep, you are going further back in time. So this record is actually going back as far as 6.5 kilo years. And what you see in terms of weight percent carbonate, the weight percent carbonate was maximum. So the sediment composition during this time was mainly carbonate rich, and the oxygen isotope is quite depleted. They're quite depleted. It means that it was a wet period, but that's why the sediments were mostly carbonate rich. And in terms of the ostracod count, there were a lot of ostracods present. So it's about between 10 and 20 shells, each 25 grams. So that in terms of paleoclimate, it means a lot of ostracods are there. And so the ostracods were thriving. And the ostracods, the species that were there, they were very thin-walled, which is typical of freshwater bodies. So all these lines of evidence point towards a deep water phase that was there around 6.5 to 6 kilo years. Now, the reason why we did not go beyond this is because the water table was quite high, and when we got the trench dug, the water started coming up, so we could only go up to this. But I'm sure the lake sediments were, from what I could see from my eyes, these kind of sediments were going further down, and it would be interesting to see later on if we could get a sediment core from this region, that how far, when exactly the lake appeared in the region in the first place, and how far this deep water phase go. But for now, I'll go towards present. And what you see after that is actually a shoaling phase. So you can see that the carbonate content is actually coming down, and it's about 40% average. And oxygen isotopes also are less depleted, so they're more positive, which means they're kind of going towards a drying phase. And the species of ostracod changes. Now, ostracods are very interesting organisms. Their species changes depends on the salinity of waters. So if it's an evaporating body with more salts present, the species changes. So Cyprides turosa is a typical ostracod shell which is present in highly saline waters, and it can tolerate high salinities or evaporative sort of waters. So these lines of evidence again point towards that there was a change in sort of a lake water chemistry, and also lake was drying up. Or the shoaling, this was what I termed as a shoaling phase of the lake. Now, there was a distinct change in oxygen isotopes after this point. There's a 4 per mil change, and then the oxygen isotope had its own steady states, sort of averaging around 2 per mil. Now, this 4 per mil change was also accompanied by absence of ostracod. So we don't find any ostracod till the surface of the ground. And in terms of carbonate, they literally comes down to less than 20% after this point. And this we call as the abrupt drying of the region. The lake now, the picture that I showed in the beginning, is actually from this region, is an ephemeral phase. So there are gastropods present, and which is why I could get the gastropods there, and I could measure the oxygen isotopes in them, and which constitute the major carbonate content in the sediments. But it only appears during summer season, and that's when the shells appear. But otherwise, it's sort of an ephemeral phase. So all these lines of evidence point to that they were the most kind of distinct the highlight of this lake was this abrupt drying that happened around the 4.1 plus minus 1. We use radiocarbon ages dates to date this section. So around 4.1 kilo years. So what was this 4.2 kilo year event? Did it happen just here, or was it a global event? I mean, people who work in paleoclimatology, they know that 4.2 is now has been accepted that it happened. It was a global event, and so now I have flipped the axis. The x-axis now is the age axis, and we have all the variables or the proxy plotted on y-axis. So here we have oxygen isotopes from Kotla Dahar lake plotted, and we compare it with other records. So for example, this is from Northwest India. There is an example coming from Northeast India, and this is it on its own chronology, independent chronology, and it's a very good, it's a brilliant record at really high resolution. Mamlu Cave speleothem from Meghalaya. And we also see Arabian Sea records kind of, they have a peak here around 4.2 kilo year, which is indicating drying. This is done on oxygen isotopes of foraminifera. Also from Gulf of Oman, there is a dust peak in the sediments, and this dolomite concentration again points to that there was more aridity around this period, and which is why it's called aridification event. And it goes as far as Mount Kilimanjaro in Africa, and you see this dust peak, and also oxygen changes in oxygen isotopes, all pointing towards a drying in this during this period. Now there is evidence that looking for what could have contributed to this drying, there's evidence of increasing ENSO events. Now, these are all proxy records from Galapagos Island and also Pacific region. So also there was a Pacific coral hiatus reported after the 4.2 kilo years. So overall, it has been, the 4.2 event has been, which spanned about 200 years, is attributed to increased ENSO events. And interestingly, there was also a societal or cultural evolution around the same time. It was when the mature urban phase kind of transformed to late urban phase, or what people colloquially term it as the collapse of civilization. So around that time, the civilization started to evolve from an urban phase back to its village-based settlements. So it's not just a regional occurrence. There's the other civilization, Bronze Age civilization, Mesopotamia and Egypt, also report these sort of evolution or cultural transformation, or I would say deterioration in terms of the urbanism around the same period, so 4.2. So it is now regarded as a global 4.2 drying event, and it kind of contributed or played a role in the Bronze Age, in the evolution of Bronze Age civilizations. Now it brings me to the second lake. I'll come back to that lake when I join these dots together and see what exactly these lakes tell you. I'll just show you the record from the second lake, which is in the subhumid region. So this is a very interesting record. We found a trench dug already for some mineral exploration, but what you see here, not very clearly maybe, but these are all aeolian deposits. And in depth, this goes up to 3 meters. So up to about 2.5 meters, there was just aeolian. Aeolian means sand, so it's just yellow sand dunes. And after that, the shells start to appear. So in black, we have ostracods, the little beasties that I show you, carbonate shells. And in green, we have the bigger ones, so the gastropod shells. So the black ones appear right here, and the sediment composition also changes from sandy to shelly silt sort of composition. After a point, the bigger ones also start to appear. And now these are oxygen isotope measured on both of these shells. And if we try and see, you can see that there's sort of a general depletion of values in both the shells, and which we think is that the lake was evolving from a shallow ephemeral lacustrine lake to a deep permanent marl lake. Now you can clearly make out the difference between these deposits and the deposits underneath, that this is just marl, massive calcareous shelly deposits. It's encrusted with shells. So this is when the lake was a full-fledged deep permanent lake. And it's full of shells, and you can see the oxygen isotopes are also quite depleted at some point greater than -4, going up to -5 per mil. Now, both these evidence again point towards a deep permanent lake, and if they are responding to the monsoon strength, it means that the monsoon strength was maximum at this time. Now, what was the timing? Now, we dated these shells as well as most of these shells and reconstructed a age record, and we can see that the maximum the highest lake level was reached between 9.4 and around 8.2 kilo years. So this was the period when the lake was the freshest and deepest from looking at the isotopic values. Now this deepest, freshest lake was then kind of abruptly desiccated, and this part here that you see is the hard ground, and I'm literally standing on this hard ground. It's a cement slab, like it's kind of if for geologists they would know wax stone. So it is encrusted with shells and also roots, but it sort of looks like that the deep lake, if it's periodically exposed to air and aerially exposed, it would form this 10 centimeters of hard ground. So we call it as a desiccation event that happened around 8.2 kilo years. And because the shells were encrusted in the cement, in the carbonate cement, we could not take the shells out of the cement, and so we could not measure the oxygen isotope. But there's one point here, which is actually the bulk bulk carbonate that I could take out. And the oxygen isotope is, again, it's quite enriched. And enriched means that there was a sort of a drying. The water composition reflects that there was a drying around this period. Now, what I also did was I measured bulk carbonate in the entire section. Now, for those of you who do deal with carbonate isotopes, would say that this means nothing because there's also groundwater coming in that would give it its own signal. And that's why I don't interpret them as climate record. What I wanted to see was this, because this hasn't been altered. And you can clearly see that this is quite heavy as compared to the other values. So in a way, kind of corroborating our results from the shells that, this is a heavier isotopic value or enriched this part is enriched in heavier isotopes. So it means that there was a drying and desiccation of the region around that, which was about 8.2. Now, after that, we again see lake sediments coming back, but not as marl or as massive calcareous deposits, but something like before, so something between 10.5 to 9.4. And they have shells. And since the top 50 centimeters was actually cultivated, so we could not, that was disturbed, so we could not go beyond that. But what we see here is a record from 6.5 to going up to the when the last glacial period ended, so about 11 kilo years. And in terms, if we talk about, if we interpret this as monsoon record, we can say that the lake appears after the last glacial period when the monsoon intensified, and the deepest lake would represent then the highest monsoon intensity and decrease E by P in the region. And then there's an abrupt weakening around 8.2, which led to the drying of the region or this lake. And then the monsoon recovers, and there is ephemeral lacustrine sediments in the region. Now, this 8.2 is not just restricted here. There is evidence from records globally that this is the largest climatic excursion in the Holocene. And from the perspective of Greenland temperatures here, there was a temperature change, so colder by 3 degrees, and when the methane values also declined by 80 ppb. So this was really a global event, and it had its imprint in the Indian region as well. And there's now increasing evidence from all over the world. So these are lake marine ice cores. And again, this is not updated. This is from 2012. And I'm sure there's more evidence coming from. And our record actually really added to this evidence that the 8.2 event that occurred in the North Atlantic had its imprint on the monsoon that is recorded in the lake records in Northwest India. So if you look at this plot here quickly, you can see the age on the x-axis, y-axis has oxygen isotopes plotted. This is the Rivasa record. Hard ground, enriched values coincides with this flip here in the speleothem from Oman, and they call it the 8.2 event. Again, radiometrically absolutely dated. And also Dongi Cave speleothem in China also record this double dip around 8.2, which I think this is the 8.2 kilo event. And closer to the Indian subcontinent and Arabian Sea, authors report a decline in the G. bouloides, which are basically foraminifera shells. So a decline in the abundance of these foraminifera shells, which is due to lesser upwelling in the region, and the upwelling in the region occurs basically is controlled by the monsoon strength. So they think that it was the monsoon that weakened around this period, and it is. Again, it is the most prominent event in the Greenland ice cores. This was a global event, which we think we see in the Northwest Indian lake, Rivasa. Now I'll talk about the last lake that I studied. This is Lake Karsandhi. this is at the border of Thar Desert, and so if you look at the lake record, it's very different from what you saw previously from the other lakes, and which is the beauty of this region, that it changes every 100 kilometers. So you can see these white shaded white colored blocks are actually gypsum, and this was a gypsum quarry, and we were lucky to find this section already, and which was undisturbed. We just scraped it clean, and you also see these brown kind of layers in between, which are mostly detrital and full of sand, and they are not the sand that we see above and below this section, because above and below, slightly, you can see slightly here, are actually the wind-blown sand or the dunal sand. But this is more of a runoff sand that it is brought by water in the lake. So these gypsum deposited from water, so there was definitely water, but the water was at the saturation state of gypsum, and so the gypsum was actually depositing throughout the year, and which led to this massive gypsum deposit, which has over 95. So the composition, XRD result says that the composition is over 95% of gypsum, and some of it is quartz. But these gypsum definitely say that the E by P was the rate of evaporation by precipitation was so high, and there was less of fresh water coming in, such that the water was maintained at gypsum saturation rate, and these gypsum appeared. Now, if we kind of make a little log out of it and try to date it, so beyond this point there was just dunal sand. So, and we did OSL dating at GSI in India, and it was about 11.2, 0.01. So this is the last glacial period still, and we slowly progressing into Holocene. And the top dunal sand is about 3.2. So this is 3200 before present. So again, this is it goes up to present, and present day it's just dunes in that part. So what I did was I sampled gypsum every 2 centimeters and measured, extracted the hydration water and measured oxygen isotopes in the oxygen, as well as the hydrogen isotopes in the gypsum. So what you see here in orange are hydrogen isotope, or delta, and in blue we have oxygen isotopes. And DXS is a derived parameter which is from the oxygen isotopes and delta, and it would reflect on the relative humidities at which the evaporation was taking place. And then I also calculated percent detrital, because I knew how much of carbonate was there in the section and how much of gypsum. And so other than that, these two minerals, it would all be detrital, quartz and other minerals coming in from runoff. So if we look at the paleoclimate record sequentially, looking from the bottom, this is Aeolian sand, no gypsum, nothing, no measurements. But you see that measurement starts from one after the lake appeared, or the water appeared from where the gypsum started to precipitate. And you can see that although there's no date associated with it, in arid regions there's always a problem of dating, because there was nothing to date. You cannot, now people are trying to date gypsum, but it was difficult to date. But what we had was a date here. It was about 7,500 years. So, and this is dated on carbonate, some of the plant carbonate, which is again very tricky to date. These are charophytes. So I would actually, because this is not, I'm not very confident of the dates here for this part, and because there's just 2 dates, and I don't want to interpolate and make big claims. But what I am confident about is this unit. So this is the sand unit here, is which I said that it's mainly the sand brought by runoff, and it also has shells. So it clearly means that this was the wettest unit, or wettest period, if I can say, from 5.1 to about 4.3, 4.4, 4.3. Clearly, this is very well dated. Lots of dates, and the oxygen isotopes are quite depleted, or quite lower values here would indicate that this was wetter period. And also the hydrogen isotope indicate in the same direction. Now, detrital is again the runoff content, and the runoff content is again the highest in this period. So what we term this period, this is the we term this period as the wettest period of the region. Now, I'll just focus on this one for a bit. And a little bit on the relative humidities, it looks like from the X's that the evaporation that was taking place was at higher relative humidity. So again, pointing towards better climates during this period. Now, if we focus on this unit, and the reason why is that this is also the period when the Harappan or the Indus Valley civilizations were flourishing. So it was around between 5.2 and 4.6 that all the Harappan sites are seen in the region. So the orange dots that you see here are early Harappan sites. So this was between these were occupied between 5.2 and 4.6 kilo years PP, and it goes on to become more urban, and the mature urban phase, which archaeologists call it, is the urban period, and that's where these regions were kind of inhabited. But after this, the oxygen isotope as well as the del D kind of gets enriched, which we term as the drying period. And there's also no shells here, and this is a massive gypsum unit that I showed you. So we think that it's the drying of the region. Now we don't have the exact date when exactly it dried out, and since the abandonment of these urban sites happened around 4.1 kilo years, and it's difficult to say where 4.1 is here. We definitely know that it's between these two units. What is interesting still is that the wetter period here coincides with the urban phase and urban settlements. And then when all the post-urban sites, as the archaeologists report, are located eastwards of this lake here. So the kind of the eastern migration of the sites is actually following the monsoon front, which is coming from the Bay of Bengal. And we also see that in these records that, after this period, there was a relatively decline in rainfall in the region, and also E by P, greater evaporation rates maybe in the region, and hence the gypsum deposits. So it kind of, the archaeologists really like this record, and they were thinking that it could have played a role, and they are doing further research onto what role it might have played, or what inferences can they draw from this record right there. Now, like Livio introduced me as the somebody who did pioneering work, but I would disagree. Actually, there's lots of records from there, and he was being very kind, but there are already lots of records from Northwest India, but most of the records are from the Thar Desert. And in fact, pioneering work was done by Professor Gurdeep Singh, and he used pollen records from these lakes in the Thar Desert. So if we look at these records and make big claims on the archaeological settlements, it won't do justice. So what I tried here is put together all the lake records that are there to see whether or not they give a coherent story. So we're going from east to west. Precipitation gradient. We have Kotla Dahar that I just showed you. It starts from 6.5 kilo year BP to present. Rivasa is here. There was alien sand and top was disturbed, so it only comes up to 6.5. This one is actually till 6.7, 6.5. So they just meet basically. And Karsandhi is the massive sand and gypsum deposits that I showed you. So it's plotted on this age scale. And there's Didwana Lake, where this is lake levels inferred from pollen and carbon isotope record. Now, this is not my work. This is from previous researchers, and they've been attributed to in this paper that came out in 2020. And Lunkransar is a lake here in the Thar Desert, and these are again lake levels from pollen records and carbon isotope data. Now, what is interesting to see that all of these lakes appeared after the last glacial period. So around 11, so Karsandhi and all the lakes in the Thar Desert appeared after the last glacial period. But after that, they have divergent climate histories to tell. So early Holocene, as you see, was actually quite eastern lakes, like both these lakes up to 6 kilo years, they record really higher sort of high lake stand, and they all reflect that it was the wettest period. But as we go further in time, it kind of started showing sort of a decline in lake levels. While the Thar Desert early Holocene record suggests that there was ephemeral lakes, and they were not the maximum lake levels of these lakes. So So high E by P rates of evaporation and lower precipitation could have contributed to ephemeral nature of the lakes in the Thar Desert. And so all these three lakes, including Karsandhi Lake, which is there, which I talked about, show not the deepest fade during the early Holocene. And when I talk about early Holocene, I'm talking up to 6 kilo years. And after that is the middle Holocene. So by 6, they were not about 6.5, I would say. They were not in the maximum lake phase or maximum, they don't infer highest monsoon strength. But so we attribute it to high evaporation by precipitation ratio in the Thar Desert and a lack of large drainage basins in these lakes. But if we move further, in time, the mid to late Holocene, these eastern lakes now are kind of ephemeral, but they had high lake stand in the middle Holocene. So around 5 kilo years, both Lungkrensar and Didwana say that they were at the freshest phase, or they had high lake levels. Now we think that it could be because of lower E by P ratio in response to the decreasing summer insolation controlled by precision. And you can see that the net effective moisture in these lakes in the Thar Desert therefore kind of was high, and therefore during the mid Holocene they record high lake levels. And also there are papers which indicate that there was additional moisture from northeast coming in as well in the lakes, and that's why. So it was in the freshest phase during the mid Holocene. Now, after that, there was a progressive drying, and Lake Kotla Dahar, for instance, dried. Now it's a dry lake; it's an ephemeral lake. These lakes kind of dried out. Karsandhi has Karsandhi has dried out. There's modern dunal sand. The red dashed line should be here. Somehow it has moved down, but you can see that the progressive drying of lakes can be seen. This Lake Lungkrensar, which is the westmost lake, it dried out first, and then followed by Didwana, followed by Karsandhi, and Kotla Dahar is still a lake, and there's an ephemeral kind of deposits there, and it appears during monsoon season. So now, what about the climate abrupt events? It looks like that there's the 8.2 event was recorded in Rivasa only, while these lakes did not record the 8.2 record. So these are the lakes in Thar Desert. These three lakes, they do not record 8.2. And the reason is for recording 8.2, you need to have sensitives. You need to have the deepest phase or the marl deposits, which are, when exposed to air, they would make this sort of a hard ground. But if it's already an ephemeral lake, and around this period, it would not make a wax stone or a hard ground. So it would not ideally kind of record that kind of a climate excursion that happened globally. While the 4.2 also. 4.2 also is not very well recorded in most of these records. And again, there are several evidence which kind of suggest that there could be, there is more moisture coming in from winter monsoon or western disturbances, which kind of maintain these lakes, and the abrupt decline or the abrupt decline monsoon that is recorded in Kotla Dahar is not seen in these lakes. So now globally, if we see other records, other marine and other terrestrial records, you can see that now age is on the x-axis, we have y-axis as proxy data. So we can see that this record combined, Rivasa and Kotla Dahar, kind of follows the summer insolation, 30-degree north insolation, and this is also followed by other speleothem from China and Oman, which are known as good recorders of the summer monsoon. And this record from Arabian Sea is actually pretty flat, but I'll talk about this record in the later slide, a little bit on this. And then there's also a leaf wax record from Bay of Bengal, which is beautifully recording the insulation. And then there's foraminifera record, very scanty, not very well dated, but you can see that, the events, or the 8.2 drying event is kind of documented in some way in these records globally, and it also is recorded in lakes in Northwest India. And similarly, the 4.2 drying was recorded in these. If you zoom in, you can see there's drying oxygen isotopes of speleothems in both of these records, and then also here in the foraminifera. Now, these are other records based on different chronologies. What I am trying to say here is that these the inferences that I've drawn from Northwest Indian lakes are not regional. It looks like there was a global imprint. They were global events, and these were recorded in other records also. So apart from these, there were other events, 9.4, 10.4, and 11 that are there in the lakes, and there are there in the other records from China, Oman, and marine records from Arabian Sea as well. So we saw the Northwest Indian lake picture, we saw global picture. Now a little bit on the this comes from Alina Geshe. She was a PhD student after me in Cambridge, and she continued working on records from in Rajasthan. And what she did was she tried to see what was the change in winter monsoon in the region using this Arabian Sea core that I was showing, that it shows pretty flat results. So using this core, and what she did was she did different foraminifera. So foraminifera are the shells that live in the ocean. So there are some which prefer living in shallow waters, and there are some which live in the thermocline or deeper waters. So the way she did, so for example, this Deutetrae lives in deeper waters on the thermocline region, and G. ruber and G. seculifera are all shallow dwellers. So what she tried to do to understand was she tried to understand the mixing, and a period of increased surface mixing basically in this region indicates that the winter monsoon was strengthened. And what she finds is that between this period, so this one which lives in mixed waters shows that between 4.5 and 4 there's high moisture. So now this is all oxygen isotope, so you can see that it shows that this was a wet period, and which kind of indicate that the winter monsoon was strengthened during between 4.5 and 4.3 kiloyears for 200 years. But after that, or if other records are placed side by side, we have Karsandhi here, Kotla Dahar here, and also Lake Rara from Himalayas in Nepal here, and they all have kind of documented. Now again, these are all based on various chronologies, and it would be nice to have them all on one chronology, or at least have one software to kind of deal with the dates that we have. But in general, you can see that Lake Rara, this N-Deutetrae, which is basically suggesting winter monsoon. Kotla Dahar from our record, from our study, suggesting that that there was a drying period that occurred around 4,000 plus minus 0.1. So we usually, it's between 4.2 and 3.9. And other surface dwelling species clearly indicate that the runoff decreased, and the oxygen isotopes are indicating that this was a drying period. Now this is the cave from Meghalaya, which has a very clear, distinct dip in oxygen isotope, which suggests that this was a drying period. So 4.2 is documented in all of these, going from west to east on all of these records, be it marine, be it caves, or be it lakes from Northwest India, and also a high altitude Lake Rara. And so all in all, if I plot the Northwest Indian lakes, Lake Rivasa and Lake Kotla Dahar together, this I've shown already, that they kind of follow the insolation curve, the summer 30-degree north summer insolation curve, and they have events like 8.2 and 4.2 kind of recorded, and they also, the lake starts when the kind of lake appears or the basin gets filled up in the lake around 11 kilo years, and the events like 10.4, those are the events that were kind of manifested as sediment changes and also oxygen isotopes change in oxygen isotope in Northwest India. Now we're comparing this. This is Northwest India and this is Greenland climate. So such close correspondence clearly indicate that these lakes are actually recording the global monsoon signal, if I may say so. And these events are all recognized in the geological time scale. Greenlandian 11 kilo years, there's 8.2, North Griffin and also Meghalayan around 4.2, but 4.2 is still believed that it was the ENSO frequency, increasing ENSO frequency, and the coral records also suggest that there's a hiatus in coral around that period, which is and increased ENSO events and a negative IOD in the Indian Ocean kind of led to increased subsidence on the Indian subcontinent, which possibly could have decreased the strength of monsoon and led to this 4.2 weakening of monsoon. But I mean, these are all model studies, and we still need more studies to actually understand what these events were like. But from what I'm trying to say from these records is that these two Northwest Indian lakes do have similarities with the global events that we see. Now, so the take-home messages again from this talk are that the lake records that I showed, Northwest Indian, just not the ones I did, but also the others, are all very important archives. Although we have to, when we look at these lake records or from anywhere in the world, we need to understand what is actually controlling the lake, not just lake or shell isotope, but also the sediment changes. So if we use just one record to talk about societal changes or changes, ecological changes around it, it would not do justice to the science. So, but the paleoclimate records from Northwest India provide compelling evidence of significant regional differences in the timing of monsoon responses to abytal forcing, like I just showed. And only subhumid and semi-arid lakes indicate gradual monsoon weakening following the northern boreal summer insolation during the Holocene, and then they also record the abrupt events. The arid Thar Desert Lake, including Karsandhi, they record more of a regional hydroclimate history. They had different E by P during that period, and also different monsoon records. Now, these records demonstrate that it is not appropriate to examine the impacts of past and future climate and societal changes in the entire region based on just an oversimplified global monsoon signal or just a single regional record, like I was saying. So I'll end my talk with thanking a lot of people who were involved in the work, and Professor David Hodder, my PhD advisor, and Dr. Cameron, who was the archaeologist, and others who have worked in this work throughout my PhD and after that. So thank you, and I would like questions.
Thank you, Yama. Excellent presentation. I just want to clarify what I mean by pioneering. I still consider your work pioneering. It's the right proxy at the right place. For example, you started to discuss work in the Arabian Sea by Guichet, which is very controversial. I happen to have a completely opposite view of what those means, but those proxies are extremely complicated. You derive the oxygen isotope, you assume the movement of the foraminifera. So it would be good to consider all point of view, but also to look for simple proxies like you used to show the annual signal. So my question to you before opening the floor for other questions is, what do you think would be the right next move to look at seasonality in those lakes?
Sorry, I didn't get your question.
What would be the right next move to look at those sediments from the lakes, to look at seasonality? Winter versus summer monsoon.
That's actually something I've been thinking upon, and ostracods could be a very good, like they could be good indicators. There are some which prefer summer season, and some of them, I don't know which because I'm not an expert. Professor Jonathan Holmes, he did a lot of ostracod work at UCL, and he was the one who were. But it could be, and we were in talks about looking at ostracods in the region and looking at what was the seasonality like, depending on the abundance of various ostracods and also their isotopes. So ostracod could be one choice that we could use in the region.
How about the gastropods? Don't they have seasonal layers, or maybe shells that bivalves that have seasonal signal? That would be wonderful to do.
Bivalves, yes, but gastropods are more annual recorders. So they live throughout the year, and they also precipitate throughout the year. So they're just recording it. So when they're literal, sometimes they're on the littoral region, like so they would record annual waters, but not season. So other shells, bivalves, yes. They have annual banding, they have seasonal banding that can be used, micro drilling, but not gastropods, I would say.
Anybody that has questions, please send them by chat or raise your hand so I can give you the floor. I'm kind of a bit disappointed, and I would like to find a solution for this. I'll talk to Peter and Tara. It's very local audience. So either people prefer to see this on YouTube, like I do when I'm not hosting, except of today when I forgot. But something needs to be done because this is a wonderful presentation, and we have entirely Indian presence. So just putting ourselves into that time frame now, literally in the time frame of that time zone, it means that people don't wake up to see it. So something needs to be done. But I see Stefan Steinke put a question, and he is not from India. So I'm already contradicting myself.
If I can add something.
Oh, Jeroen is here. When did you pop up?
Just 3 minutes ago. But because of the schedule, the talk would just be starting now. So there's something
that was the problem.
Yes.
What the hell is going on? You guys changed the time zone?
No, we didn't. No, it was said 3 o'clock in Beijing, but here is
but people, I mean, all over the world, they changed from the summer time to winter.
No, we didn't change. So
we did change a couple of weeks ago, but on schedule A it was correct. So for last week it was fine.
Okay. We'll have to fix this, and I invite you to see the talk for Yama on YouTube. But we have a hands up from Rajiv.
Liviu, I don't know, there was some problem because the mail I received from Peter, in that the timing was mentioned as 12:30 p.m. Somehow I missed it.
Yeah, my vote for these kind of lecture is to keep them at the same hour, and people who can make it, okay, they can make it. People who cannot make it, they see it on YouTube. Why change this? I mean, it's we had this kind of happenings before, because every country in the world changes from summer to winter at a different hour, and it's a mess up. Peter just checked up this with Tara last week, and we thought it's all right, but it's not. So anyway, my apologies for
no, it's fine. It's fine. It's fine.
But
It's okay.
we
No-
have a
no- no
backup
issue.
on YouTube. So
Exactly.
let's keep ourselves asking science questions to Yama for
Sure.
the people who saw the presentation.
Sure. Yama, I have a general curiosity. Like, see, these lakes are very localized. And, you know, in India, if you look at the precipitation, I mean, it's so different in different parts. You don't see any coherent picture throughout. So how these records compare with, say, different lakes, or say, for example, the marine records, because marine seems to be a very sort of an averaged out signal. You have those rivers bringing in precipitation and, say, water throughout the year, and then the sediments, currents are taking that water all along the eastern and western margins. So signal gets almost distributed throughout, and it's in a sort of an average. But these lakes are very localized. And so is there a way to put things together, and how do they match with, say, marine records?
Yes, actually, that's a very good question. And in this talk, if you see on YouTube, this has been my kind of goal to say that. And there's this paper that came out. Sorry, I'm advertising myself. This is a paper that I wrote in Oceanography 2020, and the paper actually focuses on what these lake records really record. Is it a global monsoon signal which are recorded in? What do lakes, for instance, in Northwest India actually say? And there's a figure, if I can bring my slides quickly, and there's a figure where I kind of compare all these lake records and see what.
I think there is some network connectivity problem with it.
Yama, the slides are not moving, so I think it's fine if you can explain.
Hello, can you hear me? I think
Yeah.
we lost Yama. I think we lost Yama.
Yeah, she has some network connectivity problem.
Aye.
So, Livio, this is A.K. Gupta from IIT Kharagpur. I hope you may be remembering.
Welcome. Hi.
Yeah, so how are you?
Good. Everything okay? It's
Great.
a bit early here. I didn't expect it to be that early. I prepare myself for the afternoon. It's a complete confusion in my head.
Yeah, the Peter Clip's email says 12:30, but the slide says 11:30 time. So
I see. Okay, we need to fix this.
Yeah, so there was
it was a nice lecture, so it's going to be for everybody on YouTube.
Absolutely.
I think we should end now because it's 15 minutes after. And I'll wait for you next week where we have another talk.
December
from
1st.
Kathleen Johnson. And I wish you all a very good week.
Yeah, you too.
Thank you very much. Bye-bye.
So we leave now, or Yama Dixit is coming to...
It's just too late now, so I'll send her an email.
Okay.